A very common type of question that comes up on the diploma with respect to Lenz's law has to deal with these induced current and the wire situations. They're actually not hard questions. The problem is students start to get tripped up because they kind of forget the general purpose of Lenz's law is that the system will always try to oppose any sort of change. So for these induced current in the wires, we're going to use the third hand rule. So we're going to use that relationship between magnetic force, magnetic field strength, and current direction or velocity depending on what's going on. We just have to be really, really careful. If you're asked to find the induced current, what we're really just asking you to do is to find the direction of the electron flow, since this is the definition of electric current, because again in Alberta we don't use conventional current. Now here's where the whole Lenz's law thing kicks in. If you're pushing a wire through a magnetic field, the system is not going to like that. By Lenz's law, what's going to happen is that system is going to generate a magnetic force to oppose any change that you've made. So for example, if I push a wire to the left in a magnetic field, the whole system is going to generate an induced current such that a magnetic force directed to the right opposes my motion. So that's where we have to be careful. We want to make sure that we understand that that magnetic force is going to oppose what we are trying to do. It's going to oppose the change. So again, with the third hand rule, we're still going to keep that open palm in the direction of the magnetic force. And again, it's usually going to be directed opposite to some applied force. Your fingers will be the direction of the magnetic field, and your thumb will be the direction of the induced current. Now what we're actually trying to find in these cases is if you push the wire, what you're trying to find is you're trying to actually find what current is going to get generated such that that magnetic force is produced to oppose the change that you're bringing about. So these aren't meant to trick students, but students still always misinterpret them. So let's just look at this. So we have a copper rod. It's shown to move at 5 meters per second to the right along conducting rails perpendicular to a magnetic field that is directed out of the page as shown in the diagram. So we want to find the direction of the electron flow through the circuit. So we know that the magnetic field, it's out of the page as indicated down here. We want to find the direction of the electron flow. Or instead of electron flow, what they're really asking, find the direction of the electric current, specifically the induced current. Now this wire is being pushed to the right. The big mistake a student wants to make, force is going right, problem solved. No, that is the direction of the applied force. When we're applying that third hand rule, we want the direction of the magnetic force. So if we're pushing this thing to the right, by Lenz's law, a magnetic force is going to be generated to the left to oppose that. So we want to note that first because that's really important. And that's a real key distinction in here. Because if we get the direction of the magnetic force wrong, then you're not going to get the question right. So yeah, in this diagram, we have the applied force being supplied by the person, but then this system is going to generate a magnetic force sort of to oppose that motion. So this is what we have going on here right now. So we have this magnetic force that's being generated to the left to oppose our motion. We are told in this problem that the magnetic field, it's coming out of the page. So for our hand rule to work here, what we need to do, and since it's electron flow, we have to use our left hand. We have to configure our hand in such a way that the open palm is pointing towards the left and that your 4 fingers, they're pointing out towards you. Well, the only way to have that kind of situation is if your thumb is pointing upwards. So if your thumb is pointing upwards, your fingers are pointing out, your palm should be pointing to the left. What this is going to do is this is going to give us the direction of the current. So in this wire, the induced current is going to flow up in this wire. So what's happening is that when this wire is being pushed, a current is going to be induced upwards, And then that induced current is going to generate this magnetic force, and this magnetic force will try and slow down your actions. It will try and oppose you. So the current flows up in the wire. They're very common diploma questions, so the main thing is don't get trapped on the direction of FM. If you have an applied force, the magnetic force you're interested in is going to oppose that.